Welcome back. We're going to talk about methods. Now, a method is a function that has a receiver argument. You're already familiar with functions taking arguments just after the function name. Now, you can tell a method from a regular function in that it has a receiver argument just in front of the function name and just after the func keyword. So let's go ahead and run our example here to kind of show what they do. Okay, so we have variable a and it's of type rectangle. This is a data type we created up here. Said, hey, I need a data type, name that rectangle, and it's of type struct. I have two different fields, width and height. We assigned the value 44 to the width and 10 to the height. Now down here, we're going to print whatever gets returned from this method. So a is of type rectangle, and since it is of type rectangle and this method here as a receiver of type rectangle, we get access to this method. We run this function here and it's receiving a copy of our rectangle here, and we can use that to get access to the field values, the width and the height, calculate the area, and then return it. And as you can see, it returns 440 and it gets printed out to the screen. Same thing with perimeter, is that we have our rectangle here, and being that it's a rectangle, we also get access to this method here since its receiver is of type rectangle, and we just run perimeter. So again, it makes a copy of our struct. We get access to those field values. We calculate perimeter and return it, and then it prints it out down here, which is 108. Now, obviously, we could do the same thing without using a method. Like up here, we had created a regular function. The function name is area. And even though the function name is area and this method is also named area, these are not the same function. So I know, even though methods and functions are both functions, but anyway, these aren't the same thing. As you can see here, this one is just a regular function, while this one has to be accessed through dot notation, so it's namespaced behind a data type of rectangle. So it's not the same function. It doesn't have any kind of issues when you run the function. Anyway, as you can see, we're passing in two different variables. Probably not the best way of doing it, because then you have to remember both of those when you execute it, and if you mess one of them up, it's going to run an error. It's just a lot easier just to pass in a rectangle data structure, which we do here. Just like the other ones, also prints 440. Little more intuitive, being that I don't have to pass in both the variables. I have this related data, so I can just access both of those fields, return area. So we're accomplishing the same thing as we are up here. One of the advantages of using a method is that when I run a method for a function, I know that that method is designed for that particular data type. Down here, let's say I have an area function. I can't remember, maybe it's calculating the area of a triangle or a circle or something else, because it's just named poorly. That's something I could run into. But you can feel a little more assured when you're running a method like, hey, I know that being this is namespace behind here, I know that this is going to accept this data type. So make it a little less error prone. Now, like I said earlier, we're passing in a copy, and kind of show that. We're going to go ahead and print our data type A, as you can see here, which is 44 and 10. And we've created a function, conveniently named does not change. And it's passing in just a regular variable. So this is not a pointer. And like I said, we'll cover pointer receivers for methods in another video. But being this is passing in a copy, we could print, we could print that rectangle, and it's still 44 and 10. We could double the values, for each of those fields. We could print that. We could say, hey, yep, I can see it changed those values. And obviously, this is a copy, so this does not have an effect, outside of there, because it's just in a different memory space. So when I print A again, it never changed. It's still 4410. So one thing to be aware of, just make sure you ask yourself, do I want to change the original struct or data type that I have this method attached to? If you do want to change it, you'll want to use a pointer. If you don't want to change it, make sure you just pass in a regular variable like we did right here. And another thing to be aware of, we attach this to a struct. You can actually attach this to any data type that you would like. You'll see it very commonly attached to structs because it'll give you access to many different fields in that struct and can just make life a lot easier. So, well, I hope that was helpful, and I'll see you in the next one.